record a quick video on matrices. This is going to be really easy. A lot of this is just definitions, and so we're going to kind of run through the basics. Essentially, a matrix is a way of organizing information, and it is consisting of a number of rows and a number of columns. Rows go horizontal, so that in this matrix, matrix A, you have 3 rows and you have 4 different columns. Each number inside this matrix is called an element. And you can see down here, you have a matrix, and it is, instead of the numbers here, we have A11, A12, A13, A21, A31. That's not 11, that's not 21. Those are positions. It's telling you which row and which column that matrix exists in. For example, A23 is in the second row and third column, right? So 1, 2, and then 1, 2, 3 gets you to this position. The essential coordinates, really, of these elements are denoted by their subscripts. When you write out a matrix, the dimensions are always written row by column, right? 3 rows and 4 columns. This is kind of important because in some of the operations, you have to make sure that these things are the same, and when you compare them, if you get one backwards, then you would do the operation wrong, and it would just add a lot of confusion. Okay, so once again, a matrix is just a way of organizing information. Each one of these things are called elements, and the dimensions of a matrix is simply the number of rows by columns. In order to do some of the basics, we're going to talk about some of the traditional elements or types of matrices. A square matrix is just a matrix that has the same number of rows and columns, right? This is a 3 by 3, 4 by 4, 5 by 5, all the above. These are square matrices. A square matrix is nothing more than a matrix that has all zeros, plain and simple. An identity must be a square matrix, and it must have a single diagonal. The very first diagonal must be all ones, and every other element must be 0. Row matrices are literally just with one row with any number of columns. A column matrix is just the same, but it has one column and any number of rows. Here we go, just some practice here. The dimensions of this matrix are actually, you can pause this. This dimension is 2 rows inside 2 columns. So we would end up with 2 by 3 matrix. And then the next one, we have what the second row is a column. We could talk about the 2 by 3 create a matrix with these elements. Look like this. 1, 1 position would be -9, 2, 3, second row, first column, 4, second row, second column. Inside a matrix, you can have numbers, you can have symbols. Okay. The really most important part of the matrix is how to add the rule is number 1. If I'm going to add a matrix, I have to be able to add such a way that the matrix dimensions of each of these you're adding together or subtracting. They must have the same elements. If they do not have the same dimensions, it's possible. So, we're going to add a matrix together. Which is -2, and negative pi plus 3 pi is 2 pi. When I add matrices together, you will add the corresponding elements. So in other words, 1, 1 gets added to 1, 1, 2 gets added to 2, and so forth, right? You have to add those corresponding elements, and the same way when I subtract. However, I want to call your attention to one piece here. Notice the way they're being added together. It's a plus b. If I turn that around and did b plus a, because we can add it in any order, it doesn't really matter. Subtraction is not commutative. I can't just switch these things around. So when you do that, be very careful. And this one, we're going to go backwards. So it's going to be negative 6 minus 6, and 7 minus negative 3. And kind of work it backwards in the right order. So negative 6 minus 6 is negative 12. It's going to be 7 minus negative 3, which would be 10. And then it's going to be negative 1 minus 0, which is negative 1. And then negative 7 minus 14, which is negative 21. And then negative 5 halves minus 1 half would be negative 6 halves, or negative 3. 3 pi minus negative pi would be 4 pi. I subtracted the B matrix minus the A matrix. And that's it. Take a minute and work through these problems at the bottom, and then I'll put the answers on. Okay, there you can see the solutions. Hopefully you did this right. Notice in the second one, there are a few things that I couldn't actually do the operations with. I could have gotten a decimal, but I just left it this way. Sometimes we'll be dealing with variables. Instead of 2 pi, you may have x, right? And you can't actually do x minus 6, so we'll just write it that way. If you have an operation that is not a whole value, or you're dealing with variables, then you'll simply write the expression in like I've got here. I could have written these out as decimals, but I didn't want to do that. I also wanted to show you here at a plus c. A is a 1, 2, 3, 3 by 2, but matrix C is a 3 by 1. Those do not have the same number of elements, and so therefore I cannot add them, so it is not possible or no solution. Caution, whenever you have something like this, do not leave this blank. If you cannot do it, you need to tell me that you can't do it. It's not possible. Don't leave it blank. That makes me think that you don't understand how to do the problem, or you didn't get a chance to try it. So always add something in there to say no solution, not possible, or anything like that. Okay? Important parts of this lesson is the fact that you need to know how to add and subtract matrices, and you need to know the definitions. Okay? Once you do that, the concept check is online. You get 20 minutes to do that. Pretty straightforward. If you understand what we did in this lesson today, that should be really easy. Make sure to do that writing assignment as well. It's due by the end of the day.